So let's work a little bit with exponents. Now, there's a few different methods that we can use to work with exponents, and they each have their pros and cons. And probably the most straightforward method that you can use is just to manually do things. Like, so for instance, if you wanted to see out to the screen the result of 2 squared, well, 2 times 2 is just the definition of 2 squared. It's pretty easy to understand this, and no surprise here, reliably, we get our 4. And if you wanted to do 2 cubed, then well, likewise, there you go. There's 2 times 2 times 2 for 2 cubed, and there is our 8. And you can see that this works well for small powers of 2, but if you had a very large power of 2, well, it might get a little bit more hairy to, type it out, to read it. It's error prone. How many 2's are this? Do you know as the coder? Does the reader of your code know? You have to count, and that lends itself to mistakes when there's a large number of them. And well, fortunately, there is an easier way to do things than this when it comes to doing exponents. Now, there's a con to the other way, and I'll explain that in a minute. It's easier to understand, but we have to include this library. So we have to include what's called the CMath library. Now, C++ is commonly used to program small microprocessors. And anytime that you include a library, it's as if you're including, hundreds or thousands of lines of code in with your own code, and that just uses resources. And sometimes with these small microprocessors, you don't have all that many resources to use. And so if you can get away with, in those cases, not including a library and just doing the math manually, well, yeah, do that. It actually uses less resources to do it the other way, and it's especially convenient for these small powers. But if that's not possible, or if resources really aren't a concern, well, then yeah, go ahead and include this CMath library. And inside of this CMath library, there's this function called POW. And when we use a function, well, we have to call it by name, and then we include a set of parentheses. And remember that we give functions inputs within these parentheses, and the POW function takes 2 inputs. The first input is whatever it is that you want to raise to a particular power. And so let's go with our previous example. Let's say that we're trying to do 2 squared still. And so we want to raise 2 and to a particular power. And so that's our first argument to this function, the first input. And after we put our first input in, because there's more than one input, we have to put a comma after it. We have to comma separate all of our inputs. And so the second input to this POW function is how far do you want to raise this to? Well, we want to square it, say. So we're going to raise it to the second power. And easy enough, we are done here. And this works just like saying 2 times 2 manually. There is our 4, but the cool thing is that you can raise this to higher numbers. So 2 to the 24th, instead of typing out 2 times 2 24 times down here, well, you can just do it easy as that, and there's our answer. It's in scientific notation, but it is our answer nonetheless, and it is correct. All right, so all of that being said, you can also take roots with this POW function. If you're mathematically savvy, you know that you can raise values to fractional powers, and that is the same thing as taking the root of that value. So if we wanted to get the square root of 4 here, well, if we raise it to the half power, the 0.5 power, the square root of 4 there is, well, 2, as expected. So no kidding. And we can also do this with fractions here, but be careful if you use fractions, because they need to be floating point fractions. For instance, if you do integer division here and run this, the square root of 4 is not 1. Now, why are we getting a 1 here? Well, because of this integer division, as I've said. Because, well, what happens when you divide an integer 1 by an integer 2 is that it gives you a result of 0.5, but because we've divided integers here, it's going to give us an integer answer. And basically, it's just going to truncate off any fractional portion. And so when it truncates off that fractional portion, the answer is 0 now. And so it's like raising this 4 to the 0th power. And if you're mathematically savvy, you know that anything raised to the 0th power is 1. 7 million raised to the 0th power is 1. So 4 raised to the 0th power is certainly 1 as well. So anything, if you do this, you need to do this with floating point division here. So 1.0 divided by 2.0 should suffice. And now when we get the square root of 4 like this, we get our 2 as expected. You can also use this POW function for inversions. What I mean by that is say that we're going to, raise 2, and we can do this to the, say, negative 2 power. Well, anytime you raise something to a negative power, it basically inverts this thing. So to be 1/2, be 1 over 2, because 2 gets inverted there, and then that thing gets squared. So 1/2 gets squared, so the answer should be 1/4 or 0.25. And when we run this, there you go. There is your 0.25. So this function works just like, exponents do in regular old math. And if you know how to use exponents well in regular old math, then you know how to use this function well. It's pretty straightforward. All right. See you in the next one.